Hi guys, Steve Welder Design. A little while ago I had to repair a G-clamp, cast iron G-clamp. It had fractured across here, as I usually do. I decided to try a method which I wasn't sure would work or not, and that was to braze it. The rods I was using, which is the same rods I'll be using today, are these. These are, I'm not sure how well they are around the world, but these are Sif Seal copper number 968 rods, brazing rods. And the description for those who need to know is they're a copper rod containing 3% silicon and 1% manganese. So they're 2.4 mil diameter. I work in millimeters. I know Americans don't. I can't think of, or some parts of the world they don't. I don't know what the equivalent of that would be off the top of my head. But this is the rod. Nothing sort of special to see there. Sort of typical sort of brazing rod. But it is for TIG work. Today I'll be doing TIG welding with it, or TIG brazing with it. This is a little vise, little 4-inch 100mm vise, again cast iron in design. Nice little handy little tool. Now that's as it should be, all works nice smooth. This is the one, and this is our job today. The base, if I get the camera and show you here, is broken. You can see quite clearly, as it should be, not like that. So what I'm going to do, the first job is, if I just put the camera back up there, first job would be to dismantle it, dismantle the device so that we can get good access to it and go from there. Okay, so that'll be my first job. There we go. Alright, got this bit taken off now, and this is our problem area. As you can see, that's what we need to repair, and that's what our job will be today. Some people may think, and they're not entirely wrong, that you can repair cast iron with normal mild steel equipment. Certain cast iron jobs you can, or at least depending on what they do, it might be alright just as a sort of a quick temporary fix or something. This sort of cast iron is made up that you can't. A good way of testing it is to run, if you've got a MIG welder or anything like that, run a little bead along there, get a chisel and a hammer, knock it off, or try and knock it off, and you'll see that if the weld bead doesn't want to break off, then it'll be fine and it's bonded well. If the weld bead breaks off completely and leaves the grain of the cast iron showing, it isn't any good. You will not be able to fuse weld it with mild steel in that case. And this is a little test that I've done here quite a long time ago, just to sort of see, and I've been in storage, and now is the time that I can sort of show you how to repair it. So in this case you can either use sort of a stick weld and try and repair this with a stick rod. A metal spraying, if you've ever heard of that, you could do that if you've got the equipment, but that's not so common now. Or you could go for the TIG welding, which is what we're doing. We're doing the TIG brazing today. You could do probably a high nickel TIG rod, and that would probably be alright as well, high nickel content TIG rod, but I haven't got any of them. But as I say, I've got the brazing rod, so we're going to do that. So what I'm going to do now is go ahead and prep this so it's all ready to start, or being tacked up, and we'll go from there. Okay. One thing I'll say one thing I'll say before I carry on, I was just about to start prepping this. There's a little tip. One thing, the nice thing about cast iron is that because of its structure, as you can see there, the way it sort of snaps off, if it ever breaks off, it's quite nice and easy to locate again. So you use that to your advantage when locating it, that you can put it back as it was. And a good point is if what I'll intend to do now is prep a little corner piece. So I'll prep a little bit there, I'll grind a little bit out, and I'll braze that, and I'll grind a bit out here, and I'll braze that. And what that does is it holds it in place then for the rest of the time, the way you can prep. Obviously we've got a fixing hole here, so we need to sort of prep around that, repair that, and then probably drill that out again. And so on across there. But if you tack it together in a part where it's all located, and then you know it's in exactly the right place that it needs to be. If it was in a different scenario and this hole needed to be exactly where it is, and you sort of guessed it might be wrong, so use the grain of the cast iron that's where it's broken to locate properly and go nice and see it sort of holds itself together, so you can get like that. And then also when it's tacked down there, it will allow us to start prepping the bits up here that you might need to do. This is I'm doing it again as a trial with the brazing rods. They're not suitable necessarily for every application like that, because they are a different colour. They are obviously a copper bronzy colour as opposed to this. So, but the nice thing about the TIG with the DC is it heats it up and in a nice uniform manner, as opposed to the arc welding, which instantly pinpoints and can cause other stress cracks and breaks in another way. So in this case it's not a life or death scenario. It does bond well in my experience with the G clamp. So, and it because you've got the fixing points there and there, it doesn't matter. This isn't for every application. You've got to pick and choose when and where you need it, but if you've got it available and you've got the know-how, then give it a go sometime, it might be fine. There you go. I've just this is a brazing rod I'll be using. I've just ground out these two bits here sort of to prep them, and I'll be filling them first, as I've just previously said. I've got 2.4 tungsten red tip and a number 8 gas lens, so I'll be able to sort of get in there and braze. It doesn't have to be, when you're doing this, too close like you would with, say, sort of mild steel or something, because you're using the arc as a heat source to sort of generalize the heat, and then it will just melt with the thing. So sort of my procedure would sort of be like that. So that sort of thing, and over here. And what I'll do is I'll set the camera up sort of something like that and see if I can get some arc shocks for you. Okay, I'm just about to tack, so And there we go. You can see we've just tacked it along there and tacked it around there. That'll be right to be able to carry on now prepping these bits with the grinder. I'll do that and then I'll bring it back in. As you can see, I've ground in there fairly crudely. But as you can see under there, I've ground in there. Now what I'm going to do is clean it up so it's all nice and clean, not sort of rusted and dirty and oily. Now I don't think it needs an awful lot more because of what this function does. You know, it's a base for a vise. You've got a good fix in there. You've got a sort of fix in there which will do, and it's not going to take an awful lot of hammering because it's only a small vise. Depends on what the job do. This is where you've got to use your initiative and see what it is. Now the crack does carry on round in there, as you can see if I point it out in there, but it's not my worth necessarily to get right in there. You don't need to. It will still, what I've got to do here, it will still hold it, so it doesn't need to go right in there. If it's something a bit more substantial, it might pay you to go right in there and repair it the whole way through. But like I did with the G-clamp that I was on about earlier, you know, that was right the way through just to see if it would work. I didn't know if it would work, and it works fine. I put a lot of pressure on there and it's good. This case it doesn't need to, so what I'm going to do is just, I've ground a groove in there. I'm just going to build it up a bit more now, clean it up and then build it up, and that'll be it. And turn the heat down a smidge. About 105 amps. Now we're just going down to 90. there we go. As you can see, it's very hot now from a bit of the residue grease. The certain types of processes of cast iron require you to sort of post heat or preheat and post heat, because as soon as they get too stressed by the heat, it will crack, because it needs to move. And you might have heard sometimes on this sort of dinging around, but there's nowhere anything's at, that's just it adjusting. But the nice thing about the TIG on a DC current is that it's just like an electronic flame, is what it is, isn't it? You know, it's flaming it in and doing it. But in this case I haven't needed to, and now it's finished the brazing process. I'm just leaving it to cool in its own time. Sometimes you may want to wave a flame round there just to sort of keep it from going, because now is the time that it would go if it was going to. But some cast irons and some items of cast iron would go a bit more, but if I pick it up I can show you that I've repaired all round there now. Come round there, it just sort of filled it up. Doesn't look the prettiest as such, but it's a repair, isn't it? So I might just go over that bit there again, actually, on the corner. But as you can see underneath, and what we'll do is we'll just clean up a little bit more when we're doing it, and that's it. That's right, that's it. This is all done, all put back together. As you can see the colouring. I was about, I'll get a bit of light here for you. You can see how it's all repaired. Everything works, and that will be good enough to fix down in the points where it needs to be. So we kept that there. Don't grind it away quite like a weld, because your mounting feet are there and there in this case, so it doesn't matter about leaving that, because that actually exerts the extra strength. Because remember, with brazing you're not fusing the material. So to conclude, we've left all that there. Doesn't bother me if I see it or not. And yeah, that's that. So silicon bronze brazing on cast iron. In this case, no preheat, no post heat, and all runs good. You might not want to see all that colour all the time, which is why I say this is a selective process. But if you want something to be repaired in cast iron, and you know that suits it, then that's cool, isn't it? Thank you very much. Again, my name's Steve. I work for Welded Design. I'm on Facebook, so look me up, Welded Design. Obviously you're watching the YouTube channels. I try and post a few channels now and again, so a few videos on the channel now and again, get it right, just to help out and teach and learn. So thank you for watching, and cheers till next time.